We define RMS current is like that. RMS current is that DC current which liberates same heat in a given resistor as given by a alternating current or varying current, LC oscillations. Capacitor is fully charged and connected across an inductor. Capacitor gets discharged, current in the inductor increases, and when capacitor is fully discharged, current in the conductor is maximum. Then capacitor charged with opposite polarity. Then when capacitor is fully charged, reversal happen in the opposite direction. So charge in the capacitor will be decreasing and increasing. Current in the inductor will be oscillating. Very good morning, all of you. Our discussion of JEE Mains 2026 January session continues. Today we have two chapters under discussion. First one, alternating current, and second one, electromagnetic waves. Okay, so these are the chapters having relatively large weightage. Okay, so let us start. Question number 1. Inductor stores energy 16 joules in a magnetic field energy and dissipates 32 watts of thermal energy due to the resistance. AC circuit of current 2 ampere, frequency 50 hertz. Then ratio of inductive reactance to capacitive reactance. As I told, let us go through the discussion given in the screen, so it will be saving time. Come on, heat thermal energy radiated only in resistor. Okay, then thermal power dissipated is given. In inductor, energy is given, while in energy, they use the word thermal energy, but we are calculating the power, 32 watts. And power is I squared into R, that is 33. That gives you calculation, simple calculation, current is 2 amperes, R is equal to 8 ohms. First we got it. Now, energy stored in inductor, everybody knows half Li square, half into L into current is 2 square, that comes to be 16. Again, L comes to be 8. Okay. Now, ratio of inductive reactance is L omega. We want L omega by R. L omega by R. Okay. L omega by R. L omega. L is 8. Omega is 2 pi into frequency. How much is given? Frequency is given here. Frequency is 50 hertz. Therefore, 2 pi into 50 divided by R is 8. 8 get cancelled. 100 pi. Here, 100 pi is 314. So, your answer is 314. Okay? The gap is 314. Come on, we go to the next question. Next question, electric current is given by I is equal to I0 T by T, the RMS current for a period of T to 0 to T second. The way we define RMS current, let us go to the explanation. The way we go to the RMS current, we define RMS current is like that. RMS current is that DC current which liberates same heat in a given resistor as given by a alternating current or varying current. Whatever heat liberated in a DC circuit in a resistor, if that heat generated is equal to heat generated by a varying current or an alternating current, then that current, DC current, we call RMS current. Now tell me, from this relations coming to be, look, I RMS square into R into T is coming to be heat liberated by the varying current, integral 0 to T I squared dt. So by definition, this expression comes, then T to go to the left, right hand side, that's why it comes to be. Now, I is given to be I0 into T, we substitute for that. So this is I0 is a constant, T square is coming outside, integral 0 to 2 T square dt, I0 square by T cube into T cube by 3 giving limits. We are getting that is equal to I0 squared by 3. IRMS squared is I0 by 3. Therefore, IRMS is I0 by root 3. I0 by root 3. That's why we get it. Answer coming to be 1. Okay. So, this is the basic definition of, I repeat it. This comes from this explanation. Whatever heat liberated by a direct current is equal to heat liberated by a varying current. And for a DC current, what is the heat liberated? Current square into R into T. That current we call IRMS. And what is the formula for liberated by that? I square dt current, dt. I square dt. Okay. Now we substitute for I. It may be a varying current like this. Here, what is the current? 0 I0 into T I small by small t. It can be a varying current, it can be an alternating current, whatever it may be. This is the method of calculation. From this, we come to the statement, substitute for I, and we get the answer. We go to the next question. Now, an alternating circuit is given, LCR circuit is given. We have to calculate power factor. Power factor. Let us go to the explanation quickly. Power factor is given by R by Z. R is the resistance, Z is impedance, root of R squared plus XL minus XL. Everything clear, very clearly given, isn't it? Tell me, XL minus XC is coming to be, or XC minus XL, whatever it may be, is coming to be 80. Then R is 60, root of 80 square plus 60 square. Therefore, impedance is coming to be, net impedance is coming to be 100. And R is coming to be 60. Therefore, R by Z will be 60 by 100, 6 by 10. And we are getting, the answer question is given to be, the value of power factor is alpha by 10. We got here 6 by 10. So in place of alpha, who is coming? 6 is coming. So very easy question. So this root of 150 minus 70 whole square, that is 80 square plus 60 square, that is 60. Correct? Then inductive reactance, resistance is given to be 60. So 60 by 100, 6 by 10. And this is alpha by 10. So alpha is 6. Okay, we go to the next question. Come on. Again in a AC circuit, given as maximum current measured is 50 milliampere. Then V is given by 5 sine 100t. Value of L and R shown in the figure. The capacitance of the circuit. First, let us calculate the impedance. So let us go to the explanation side. Tell me, how do you calculate impedance? Impedance is calculated to be maximum voltage, that is 5 divided by current 50 milliampere, that comes to be 100 ohms. First thing, what is that? Impedance is coming to be 100 ohms. And resistance is also coming to be how many? 100 ohms. So here we get impedance is equal to resistance. Impedance we got is 100 ohms. Resistance is given to be 100 ohms. This is a case of resonance. Okay. This is a case of resonance. Now, in resonance, we can find L omega is equal to 1 upon omega C, or C is equal to 1 upon omega square L, and working out, we are getting capacitance is equal to 5. So direct question, C is equal to 1 by omega square L. Omega is given in the equation. In the equation, what is omega? 100. Omega square is 10 to the power of 4. L is 2 Henry. And solving, you are getting is equal to 50 microfarad. So your answer is 50 microfarad. Isn't it? Okay. Fill up the blanks is 50 microfarad. Next question, we go to the capacitor is charged fully with potential difference of V0 disconnected from it, and the charge capacitor is connected across an inductor like this. Let us do in the next page. Yes, capacitor is fully charged by Q0 and connected across an inductor. Okay, yes. Now, this will lead to the case of LC oscillations. Capacitor is fully charged and connected across an inductor. Capacitor gets discharged, current in the inductor increases, and when capacitor is fully discharged, current in the conductor is maximum. Then capacitor charged with opposite polarity. Then when capacitor is fully charged, reversal happen in the opposite direction. So charge in the capacitor will be decreasing and increasing. Current in the inductor will be oscillating. Energy will be oscillating. So this leads to the LC oscillation. And in LC oscillations, we know that the angular frequency is equal to 1 by root LC. That's given. That is LC oscillations. Okay. Now, initially, capacitor was fully charged. How much energy is there? Half Q0. Initially, when it is connected, at that time, capacitor is fully charged. Now, after that, 25% energy is lost. Remaining energy is 75%. So, 75% means 3/4 of this. Okay? Isn't it? 3/4 of this. So, tell me what happened to the charge. Charge has become, Q has become, energy has become this 3/4. The charge has become root 3 by 2 Q0. Root 3 by 2 Q0. And you know, in LC oscillation, initially capacitor is fully charged and the charge start oscillating just like in simple harmonic variation. Here also, the charge in the capacitor will varying. Why it is coming a cost function? Initially, capacitor was fully charged. Initially. Therefore, equation will be Q0 cos omega t. Q0 cos omega t comes to be root 3 by 2 Q0. Q0 get cancelled. Cos omega t is root 3 by 2. Omega t is pi by 6. Okay. Then omega is what? Root LC. Root LC into T is coming to be pi by 6. This gives you T is equal to pi divided by 6 root LC. Pi divided by 6 root LC. So this multiple option, pi into root LC. No. What is that? Omega T is given by pi by 6. Omega is 1 by root LC, not root LC, 1 by root LC. That's a mistake we made. Look, omega is 1 by root, as I written there. So instead of omega t, we have to write omega t is how much? Pi by 6. Omega is 1 by root LC into T is equal to pi by 6. T is equal to pi root LC. LC will go to the numerator. Simple mathematics. Pi into root LC by 6. Okay. That is the value here. Pi into root LC. After this much time, the energy stored in the capacitor will be 1/4 will be lost. or it will be 3/4 will be remaining. Okay. Now we go to the questions from